Hello. So tonight we are going to talk about provider. Yeah, so there's a lot of things to talk about provider. So we won't cover absolutely everything because it's a very, very broad topic. We'll focus on the most important parts. So the title is a bit offline, yeah, I know. We'll focus on 3 different parts. First, what provider is, then how to use it, and with some common examples. So, what is provider? There's a question that recently comes quite a lot on different mediums about Flutter. Should I use provider or should I use block or Redux or whatever for state management? And I don't like this question at all, because for me, if you ask this kind of questions, then you don't really understand what provider is at its core. Because this question implies that provider is an architecture for state management, but it's not. It doesn't replace Redux. So for example, if we were to compare state management with junk food, then Redux would be your typical fries. It's a finite product, and you can consume it directly. It will work in itself. But if you don't like it, then you don't have the choice. It's take it or don't take it. Provider is more like the fryer. It's a law, obviously. But you have a lot more freedom. You can do whatever you want. For example, wrong button. You could take provider and combining, for example, with change notifier, which is how the Google team uses it, how Google use provider internally. You can, when you, for example, combine change notifier and provider, you end up with an architecture similar to what they call Scott model. But you absolutely don't have to do that. You can do literally anything. You could implement your own state. You don't have to use change notifier. You don't have any kind of restriction on how to implement your state. So what provider really is it's just a way to make it easier to pass state between your model and another model, or your model and your UI. So provider has a few objectives with let's go back. So the first one is to expose the value, obviously. But exposing the value, it's not just expose it, it also contains when we don't want to expose it too. For example, we could voluntarily not expose a variable to some part of the application. We could also, in the scope of the feature, decide when to create a variable and when to dispose it too. Because if we know when to expose it, we know potentially when we don't want to expose it anymore, and we know when we can delete it. So the second feature is to obtain it, obviously. And then similarly, in that situation, we will have different flavors of a way we can obtain a value. Usually we will want to subscribe to the value, for example, so such that if we obtain a value, then whenever something changes on our dependencies, then we are ensured that we are kept up to date with the change. And another very important point of provider is it's very opinionated on what you want to do. It will have very strict limitations to force you to have a scalable application. There are some things that you may find harder to do with provider, and it's actually desired most of the time. So if you are having trouble doing something, then maybe you should ask yourself, do I really want that or not? Because maybe there is a reason why providers don't let you easily do that. And then there is a fourth point, that is simplicity. Because if it's not simple, then people won't use it, and they will use their own stuff on their side. So if they use their own stuff, then all the other points become obsolete because they don't use it anymore. So we have to keep it very simple, otherwise it's not used. What is not, on the other hand, is provider won't try to be compatible with apps that are not Flutter-based. The main reason is, while it's a good objective to have compatibility with, for example, Angular, Flutter is cross-platform, and we nowadays have the web platform too. So technically speaking, if we have a dependency on Flutter, we could theoretically still ship our application everywhere. But at the same time, if we have a dependency on Flutter, it can simplify a lot of things on the way we can expose and obtain values, because then we are aware of how the framework works. So we can cut a lot of the boilerplate. Similarly, it's absolutely not opinionated on how to implement your state. I cannot stress this enough, because many people think that provider is just scope model, but it's not. So keep that in mind. So now what we're going to see is how widgets works in Flutter, how the Flutter architecture of your app in Flutter usually is, because provider will try to be compatible with this. And in Flutter we have a typical quote that we find everywhere is, everything is a widget. But what is a widget? Well, widget, I like to think of them as the little bits that compose an exploded view of your application. It could be the text, but it could also be more abstract components like a row or application in itself. And for example, when we make our typical Flutter application, we will have, for example, the first widget that we will write is my app. And then my app will build other widgets. For example, home, which then build an app bar, which then build a text. And potentially home will build maybe something like a dashboard, and which can build whatever, like menu items or whatever. And we could also have other routes. So we can clearly see that we can have very low level topics with widgets like text, but we can have also very, very high level topics like application. And what's very important with widgets is that they are very, very strict in how we use widgets. And that's actually very important in how Flutter works. That is, data get passed only down. It cannot go higher in the tree. Which means that, for example, if this widget contains data, then this widget will be able to obtain the data of this widget. But on the other hand, if this widget contains some data, then this one won't be able to read from this one. Instead, we will have to submit events, such that, for example, the user clicked on something, and then this widget will submit something like, it will call a callback or submit a notification, and then components higher in the hierarchy will be able to catch that and react to the change, which will then potentially update some information which will again be propagated down the tree. And one consequence of this is, for example, no, okay, yeah, wait, yeah. For example, this widget and this widget will not be able to communicate with each other. They will not share state whatsoever, and they will have to talk through a common ancestor, which also means that the widgets are extremely composable and extremely reusable. Because, for example, if we modify something in this widget, then since the other widgets here and here cannot use anything from this widget, then we are 100% certain that any modification in this widget will have no impact on the other widgets, which means that there is a very clear boundary in what's impacted or not by a change in your application. It's a very strong separation of concerns. This is what typically allows Flutter to make so powerful animations, because we could, for example, wrap any kind of widget into an animation, and then the entire subtree will animate automatically. And that concept is what we call unidirectional data flow. And it's a very core concept in Flutter. Yeah. Okay. So, what one? Okay. So what I like to use as an example to explain how composable widgets are is, technically speaking, everything is a widget, and since my app is a widget too, then we could theoretically reuse my app and do some fancy thing with this. For example, for the contest, the Flutter Create contest, I made a small example showcasing this behavior. So I made a small application that use other applications. And we have, this is 2 different open source applications maintained by the community, and somehow we have an application that uses different applications. And that's very mind-blowing when you think about it, because that's not something that we would ever do in any other kind of framework. And typically these 2 applications were never built for this use case at all, but it works by default because of how widgets are composable. So, let's go back to passing state. We will see a few alternatives on how to pass states in Flutter, with a typical example of making a team. So that's the default application in Flutter. We will want to recreate 2 features. It's the way the text of the app bar and text of the body are teamed. Like, we can see the body text is gray, but the app bar text is white. So there is something in our application that pass a state to differentiate the colors between these 2 texts. And when we modelize our widget tree of such application, then we will typically have a home page, a home widget, with then a body or scaffold, if you're familiar to Flutter, which then instantiates a text. And we'll have another branch, and a bar and a text. Nothing special here. And then the first solution that people tend to use is to have global state. So, for example, if you're using something like a global variable bar, but something like Redux or other similar patterns tend to rely on one big monolithic state. Then we find ourselves in a weird position, because our text here must have a different color from our text here, which means that we have to specify manually every time. We had to manually specify to each text which colors they need to use. But there is a small drawback to this kind of architecture, when we want to make other screens of our applications, then every time we want to make an app bar, then we will have to specify that the text used by the app bar is white. So we can easily make mistakes as the application grows as the application scales, where we could, for example, reuse the wrong variable. And that's not very funny to make mistakes, you know. So, globals. Their biggest advantage is that they're very, very simple. Basically, that's what they are at the core. But it's very, very easy to make mistakes with globals because basically you have to do everything yourself, technically. So globals won't help you, won't tell you when to create a variable, when to dispose it, when to update dependencies. It's just a variable after all. So you still have to do the job. You could, for example, build an architecture on the top of globals, like, for example, you could have a global stream, but then as you make your own architectures based on globals, then you are little by little losing the simplicity of globals. And it also promotes laziness, because globals are they have no restrictions at all, and they are very simple to make. It's like a one-liner, and we can access them absolutely everywhere. And so there is no restrictions on when we can update a global variable or when we can not update it. And so, which means that at some point we may, as the application grows, there will always be one lazy developer that will realize that it can take a shortcut to develop a feature just by using a global variable, and you will end up with a very weird dependency graph between your global. You will have potentially a cycle between your global variables, and you could, for example, have two global variables that depends on each other's. That could make the application very difficult to understand at the first read, because you will have it will be difficult to know what can modify a variable. And like I said, it gets a lot harder to change over time, because the issue with global variables is that everybody can access it. That's good when you want to develop quickly, but as the application grows, it creates a fear for the developer, because when we will want to make a change to that global variable, then it will be very difficult to evaluate the impact of this change. Potentially it won't break the application, but potentially every other part of the application uses that variable, and that's certainly broken. So yeah, in my opinion, globals tend to make what I like to call SpecDecode. So we can look at a different architecture that is built in Flutter. That's what they call inherited widgets. Inherited widgets are basically an alternative to global variables by using widgets. So if we take our previous home screen, then we could instead make a team widget that contains our gray team, for example, and put it above the home screen, such that it's available for all the widgets that are contained in the home screen. And then our text will be able to obtain the nearest instance of that theme widget, which means that our text here will be able to understand that it should be gray. But then we have this situation where we want our hotbar to override that default color. And in that situation, we will have a slight modification of the widget tree. We will still have our hotbar, but then our hotbar will create another theme inside the hotbar. But that theme will have a twist. The twist is that instead of gray, it will create a white theme. And then suddenly, all the descendants of the hotbar, when they will try to obtain the theme instance, then the nearest theme instance that they want to obtain will be the white theme instead of the gray. So suddenly this text will be white. And that's very interesting because in that kind of architecture, there is no strong relationship between the text and the implementation of the theme. We never had to pass a parameter to the text. The text automatically inferred that it should be either gray or white, which means that as we make new screens on our application, as we make another hotbar and another text, then we don't have to specify again that the text has to be white. It will be automatical. So, yeah. And another benefits of this kind of architecture is that, for example, if we suddenly want to if we want to make our root theme animated, like for example, it could change color over time, then suddenly all the widgets that use that theme will animate automatically too. That's very powerful because we never had to do anything like managing subscriptions or having a streams or whatever. It automatically rebuilds when the theme change. But at the same time, that white text used by the hotbar is not impacted by this animation. It won't rebuild unnecessarily. When this color change, only the text will rebuild, not everything else. There is also an interesting benefits of using inherent widgets. That is, they are widgets, which means that they follow the unidirectional data flow that we talked earlier. Which means that when we delete our hotbar, when we remove it from the widget tree, then suddenly our white theme instance is not linked to anything anymore. Which means that we know for sure that it's not used anymore. Because since it's not a global, then since it's a widget, only the descendants of the hotbar can use our white theme. But since there is no descendants anymore, since there's no hotbar, then nobody can use the white theme anymore. So we can dispose it. So, inherited widgets come with many benefits. Yeah, like I said earlier, they allow to create and release the resources only when you didn't need it. When you insert your inherited widgets in the tree, it will create the resource, and when you remove it from a tree, it will dispose the resource. The developer never had to really manually manage this state. And it prevents SpecDecode because, like we said earlier, the widgets are very strict in how we can obtain the state thanks to this unidirectional data flow. So we can't have cycle dependency. It's also very consistent because the default behavior is always usually the one you will want. You will never have to manually specify every time the parameter it's inferred by default. And it's also very well integrated with the tooling because since it's a widget, then Flutter is able to know how to manipulate widgets. So, for example, if you open the DevTools, you will know what's the state of the inherited widget. You will see the variable in the DevTools. You will also have things like hot reload and similar things. And it also updates your AI automatically, like we said earlier. But the issue with this is that Flutter gives a very low-level tools only. It only gives an abstract class, and every time you have to implement it yourself. And it's kind of boring. And due to this, it still requires quite a bit of code, a lot more than your typical global variables. So people tend to be lazy and don't do it. And it's also a bit of an unusual pattern at first. If you're not familiar with widgets, which many are, then you may not understand what an inherited widget is at first. So it's a kind of a mind shift. And the goal of Provider is to take inherited widgets and extract the common use cases and remove the boilerplate and make it as simple as possible. So we will keep the same features that we had, that we discussed earlier with inherited widgets, but we will only keep what most people want. Which means that we don't need globals anymore. Yay. Okay, so how to use Provider? Let's see some code. There's two main topics in Provider. Like we said, exporting the value and consuming the value. And again, we won't talk about how to implement your value because that's out of the scope of Provider. So if you're here to know how to use generative, then that's the one topic. So, exporting value. There are quite a few ways to expose the value. We have classes in the package provider that contains in their name provider. So, for example, we have provider, and each of them contains two different constructors. So the first one is the default constructor, and that provider is a widget, like we said earlier. It would take the type of the widgets that we want to create. So in our case, it could be team. Then it will take a function that will create our state. And I insist on the fact that this function creates the state. It doesn't take an existing state. Then we have a dispose callback. That callback will be called typically when the provider widget is removed from the widget tree. And a child. Then we have a second constructor that is provider.value. It still has that type team in the parameter. But instead of a function to create a value, then it directly takes a value. And in that situation, you must not use this constructor to create a variable. You should not do that because the variable that you create that is passed to the provider will not be disposed by the provider when the provider is removed from the widget tree, because this constructor considers that the variable is coming from somewhere else. Which means that if it's coming from somewhere else, the provider is not able to know that the value isn't used anymore, so he won't dispose that variable. So if somehow you use the value constructor with something that needs to be disposed, and you created it directly inside the parameter of the constructor, then you may have memory leaks, or you may lose your state, which isn't designed, obviously. And then it takes the same child argument. Ooh, wrong button. Okay. And then, as the application grows, you will realize that you will have quite a bit of nesting. For example, you could have a team, a provider for a team, and then you will want a provider for configurations, and then a provider for a notification services. But then you have many different kinds of providers, and every time each increments the tabulations, you have quite a bit of nesting. And in my opinion, that's absolutely not reliable. I don't like this at all, because it's not very linear. We cannot easily see the list of the provided objects. So provider comes with a simple syntax trigger to help with that weird syntax. So it's called multi-provider. It will take an array of providers. It can be any provider from the provider package, or your custom provider if you made one. And instead of nesting them, you can just put them next to each other. And then multi-provider will reconstruct the tree that we made previously. So in the end, that's exactly the same thing that we made earlier here, but it's a lot more readable. And then we have many different variations of providers. For example, we can have provider, but we will also have a provider for more specific type of objects. Like if you want to use change notifier, you may want to use change notifier provider. If you want to use a stream, you may want to use stream provider. And the difference with between these providers and provider is that they are aware of how the object works. So if you're using stream provider, for example, then when a new value is pushed onto the stream, all the widgets that use this provider will automatically refresh with the new value that is pushed onto the stream. Similarly, you can also use third-party packages that are usually well integrated with provider, like for example Mobex, or the library called Block, and Flutter hooks, that is a package of mine. Or you can make your own provider again. Since provider is not opinionated, then it exposes also all the tools that you need to make your custom provider and make it work with the different tools of provider. Then we may want to create a provider from other values coming from other providers. So for example, we could have a future provider that will load some JSON file and parse it and extract it into a class and expose the result. But then we want to have a notification service that is based on these configurations. So we could use a variant of the widget provider that is called proxy provider. Basically, instead of creating one value, it will create one value from another value. So we first specify the type of the values that we want to consume, in this case, configuration, and then we specify the type of the values that we want to output, in this case, hot services. Then we take, then it takes a typical builder function like all other providers that will create our value, and with the current configuration passed as parameter. we can then pass it to our out service. And the interesting thing with this is that whenever our configuration change, then the auth service will be, the authentication service will automatically be recreated accordingly. Because if, for example, in our example, then our configurations are asynchronously loaded, which means that on the first frame we don't have configurations. And then we can continue a bit further, and we can, for example, make a more complex model or something that is not immutable using change notifier proxy provider. It follows the same patterns again. It takes the types that you want to consume. So here maybe authentication services. And then we pass the types that we want to create. So here my model. But there's a little twist with the previous one. It takes two different builder functions. The first one is a function that is called the first time that the provider is inserted in the widget tree. It will create the variable, the initial variable. And then we have our second function that is the same as the one we used previously, that will receive our authentication service that we consumed, and the variables that we created earlier in our initial builder function. Then we can combine both to, for example, assign a variable inside our model, and then using such provider, then when again the authentication service change, then the model that we created will automatically update with the new variable. Okay. Now on to consuming a value. That's very straightforward. It's just provider.auth, and you specify the type of the object that you want to consume. But then the question is, if you're unfamiliar with Flutter, you may think, but what is context? Well, context is, it represents the location of a widget inside the widget tree. So for example, this widget has a context, and this widget has a context too. In fact, all widgets have a context, and each context are independent from each other. They're unique. And when we want to obtain our variable, for example, if we wanted to create a value with provider, and then we want to create a text from that variable, we may naively think that we can make such tree and directly use the context paths to the build methods that we usually have in our widgets. But there is a slight issue. That is, we used the context from the widgets that created the provider, instead of using the context of the text. Which means that if we see our widget tree, then that's our provider is here, but only text is able to access the provider. But we used the context of my app to try to obtain the provider. The thing is, my app is an ancestor provider, and like we said earlier, widgets use unidirectional data flow, which means that my app is unable to obtain provider, and you will get an exception because it will not be able to find the provider. So what we want is, we want to find a way to use the context of text or any descendants of provider to be able to look higher in the tree and obtain the provider. And to do that, we use another widget, which we call consumer. So that widget is will change slightly the widget tree that we had earlier. We inserted it directly as a child of our provider, and then consumer will use its own context to obtain the provider, which means that we won't use the context of my app anymore. We will instead use the context of this one, and this one is a descendant of provider, so it will be able to correctly obtain the provider. So our previous code could be changed to this: provider, then child consumer, which specifies the type of the objects that we want to obtain. And then it takes a function that creates a widget tree based on the variable obtained. So yeah. And then it works, yeah. Then there's a few common questions that come up when using provider. The first one is, can I use two providers using the same type? Well, technically yes, but usually that's not what you exactly wanted to do originally. For example, in this example, then someone wanted to expose two strings independently, like for example, hello and Paris. And typically what people want to do is to obtain both strings independently, but you won't be able to. You will be able only to obtain Paris in this case, which is not what you want to do. So in that scenario, what we want to do instead is to give a unique type to each individual object. So instead of using string 2 times, we can use a custom class like greeting, for example, and city. Which means that instead of making provider.auth string, then we will call provider.auth city or provider.auth greetings to obtain the 2 different values. And now we are correctly able to obtain the both. But it kind of sounds complicated, doesn't it? But there is a very big use case for this. For example, if we take our previous example of team, then we are falling into the exact situation. That's our for example, in that situation we have 2 providers using the exact same type. We have a provider at the root of the application that use team, and provider inside the app bar that use the same type too. So for example, if we wanted to implement such architecture using provider, then we would have a code that somehow looks like this. So we have our provider at the root of the application, that is our creating. Then we have our on screen, and somehow an app bar somewhere. And as a child of that app bar wants to override the theme, so it purposefully creates another provider, but with a different value this time, a white theme. Which means that now all the descendants of app bar will use the white theme instead of the gray theme. But since the body text is outside of the app bar branch, then it will still use the gray theme. Alright. Another use case of such restrictions is to potentially voluntarily make it impossible to access a variable on some screens. For example, we may have a login page and a home page. And it doesn't make sense to be able to obtain the current user in the login page because we are not logged in. But it does make sense to obtain the current user in the home page. So in that situation, we could, instead of having the provider above my app and be able to access the users on both login and home, we could voluntarily put the provider directly above home but not above login page. Which means that in that situation, login page will not be able to access the current user. And another question that comes up quite often is, for example, you have your model and you want to obtain a variable inside your model that comes from provider. So you may want to call provider of context, but you don't have a build context object inside your model. And usually you don't want to pass the build context to your model, because that would mean that your model will need a dependency on Flutter, and that's not desired. So somehow people do this. They pass the build context and they try to call provider of inside a method or whatever. So don't do that. Instead, what we usually want is to use some form of abstraction. For example, we could pass directly the variables that we want to obtain to the model, and then we can use it directly, which means that the logic to obtain the variable is then moved to the widget tree. So since we are using a provider to pass our model, then we will have a provider in our widget tree that will create the model. And since providers are widgets, they have a context, which means that they can obtain our service. So that's a typical use case for something like proxy providers that we talked earlier, where we can obtain other values and pass them to our model. So yeah, in conclusion, provider helps you to pass states around, and it tries to automate the process of creating and disposing your state. On the other hand, it's absolutely not related to how you implement your state, and it will never be. But anything that is made to that can potentially make passing states more maintainable, on the other hand, is in the scope of provider. And yeah, that's it. And there's a cap. Go ahead.